How do you take an oath? Here we see it says, I, your name, swear to honor and uphold. So the oath leader may say, repeat after me. I, your name, swear to honor and uphold. They are expecting you to use your own name and not say your name literally. If your name was John Brown, then you would say, I, John Brown, swear to honor and uphold. In C#, you can use the variable your name with the write line. Notice there are no double quotes around the your name variable in the write line. When you run this code, the program will use the current name that was assigned to the variable instead of displaying the literal your name. In the first part of this chapter, we will explore how to use variables. Let's talk about the proper way to name your variables. Variables are usually not called X or Y, but have some meaningful name. Here we see a variable called my birth date. We are not allowed to have spaces in the variable name, so we run the words together as one word. But by capitalizing each letter in individual words, we can see them clearly, even though they don't have spaces. For variables in C#, it's more common to leave the first word in all lowercase letters. Both these styles of variable naming conventions have an official term. Pascal casing is where every first letter of each word is capital. Camel casing is every first letter except the first word is uppercase. Keep in mind that C# variables are case sensitive. If you create a variable called my birth date in Pascal casing and then later try to use it as my birth date in camel casing with a lowercase m, then you won't be able to. In other words, these two variables are not using the same variable name. They are considered to be two different variables. Can you name a variable anything you want? Almost. There are a few restrictions. Variable names cannot have spaces. Variable names can only start with a letter, underscore, or @ symbol. Other than the first character, only allowed characters are letters, underscores, or numbers. You can start a variable with an @ sign, but not have an @ after the first letter. Here are a few examples of what you can and can't do with variable names. On the left side, you see names that are not allowed. 1, 2, 3, first name. Why? You can't start a variable with a number. Look on the right side and see the equivalent of what you can do. First name 1, 2, 3. Back on the left side, underscore, last name, @company. You can't have an @ in the middle of the name, but you can start a variable with an @. @last name company is a valid name for a variable. Back on the left, you see a variable with a space in the name. You can't have a space in the variable name. So user space last name is not a valid name for a variable. The equivalent allowable name for this variable would be user last name, all run together, camel case, with no spaces. Let's open up Visual Studio Express and create a new project. Go File, New Project, and we're going to choose a C# console application. Make sure you're in the C:\Joe's to Pros folder, and since this is Chapter 2, let's call this project CH2A. And click OK. The code will go in our empty main method between the curly braces. You might recall from the last lab that our code goes between the beginning and ending curly braces after the main method. In the main methods block, type the following: byte, in all lowercase letters, my num in camel case, and then end with a semicolon. This first line creates a variable type, my num. You must declare variables before you use them. The second line we're going to type will use the variable and assign a value to it. How does that look? My num equals 7, semicolon. This initial assignment of a value to a brand new variable is called initializing the variable. Now on the third line, we're going to use this variable. type console.writeLine, and in the parentheses put the variable name mynum, and end with a semicolon. But we want this message to be a little friendlier, so we're going to put a message in here with the mynum. So put a set of quotes, and then a comma, and then the variable name. In the quotes, we're going to type, your lucky number is, and we will put a variable placeholder. Variable placeholder number 0 is our first variable placeholder. The variable value after the comma is going to be placed right here in this variable placeholder. Finally, we know this program's going to run too fast. So to pause it at the end, let's do a console.readLine. Parenthesis, semicolon. Run the program by running the green icon on the toolbar or pressing F5. It says your lucky number is 7. Let's close out of the program. Let's try a few simple changes to our code. The first change we're going to make is we're going to change the value of 7 to some other number. Let's change it to 43 and run the program. Notice it says 43, and we never changed the write line. The write line is still using whatever variable value you have. This variable is a type of byte. The maximum range of a byte is the numbers can go as low as 0 and as high as 255. Let's test out 255. It works just fine. But what happens if we try a number larger than 255? Let's try 1000 and run the program. Notice we get an error. The compiler knows what the range of this type of variable is and will complain if it's not correct. In this case, we overflowed the value. We just saw that putting 1000 into a byte data type overflowed the capacity and we got a compile error. But let's change the data type and see how big an integer can go. Will this run with 1000? Let's test it. The integer had no problem holding 1000. Let's close the program. Let's see how big it can go. Let's stuff in 2 billion. That's 2 with 9 zeros. And run this to test it. Hey, it had no trouble holding 2 billion. How about 3 billion? 3 billion overflowed the integer. Well, that's actually not a surprise because ints can go from negative 2.1 billion to positive 2.1 billion. So 2 billion positive or 2 billion negative is not a problem for an integer. But actually, there are two types of integer variables. One that will take negative numbers and therefore has the lower limit of negative 2.1 billion and positive 2.1 billion for its upper limit, which is a total of 4.2 billion different numbers, or one that only takes positive numbers, one that will go from 0 to 4.2 billion. When you simply specify the int as an unsigned int, in other words, you're not going to have a negative sign, you can go up to 3 billion easily and beyond. As you can see, 3 billion worked in this program. You can even go to 4 billion, and that works. You cannot go to 5 billion, and you cannot go below 0. In other words, negative 1 will cause an error, and this program fails. Here are all the integer numeric types available to you. Byte easily handled 7 and 43, but it couldn't handle 1000 or any of those higher numbers. Its range was 0 to 255. We also played around with the integer, and we could see that it can take negative numbers and positive numbers, from negative 2.1 billion to about positive 2.1 billion. And we also tested the unsigned integer, and we tried to feed it a number below 0, which it can't accept. We tried to feed it negative 1, and it didn't work. The other data types and how they work are listed in this grid. 7 is an integer, but 7.1 is not. So if you're going to have some decimal points, you can't use any of the integer data types. You're going to have to use one of the floating data points. Now, how big can they go? Well, it kind of depends upon your precision. What is meant by that? Well, let's look at this. 5.0999999 is not any larger than 5.1, but yet it's more precise. So based on the number of decimal points, pick the right data type that will fit with what you're trying to store. And that will do it for Chapter 2.1 on using variables. Our next item, Chapter 2.2, Variables with Input.